Okay, so let's look at our first example. So actually, before we do that, let's go over a quick definition. Alright, so let's see. Alright, so for this, two quantities are directly proportionate if a change in one produces a change in the other. Looking at our first example. So we know that they're directly proportional if the change is in the same direction between both of them. On our first example, a machine produces 280 pieces in 3.5 hours. So we want to know how long is it going to take to produce 720. So, because we know that 280 is 3.5, we can set this out by saying, well, we know that this is increasing, and we know that if we're going to produce more, it's going to take longer. So it's actually directly proportional. So we just set it up right away. And now we can just do what we did on Tuesday and just cross multiply. So we got 280x equals 3.5 times 720. Cool, so we got 2520. And now from here we can just divide by the 280. And so what do we got? X is equal to 9. Cool, so it's just 9. Cool.
I mean, it's 0.9, but that doesn't make a difference, right?
No, it's just for some reason yours is set to,
Alright.
yeah.
And the base is 38.
So at this point we have a base of 38 according to this example. And then what's the height that we want to find?
From the top is 14.
So yep, so we want to find what this height, well the height right there is 14. And so what we want to find out is what's the diameter right there. That's what we want to know. Now we have to do the same exact thing. We know we are talking about the same cone, right? Same exact cone. We have the big one, and then we have the small one. So this is directly proportionate because of that. So we can set it up however we want. We can put the x on the top. We can put the 14 on the top. We just need to make sure that if I put the x on the top, should the 38 or the 35 be on the top?
35.
If I put the x on the top. So if I go x over 14, then, yep, 38 should also be on the top because that's where I put the diameter. So if I put the diameter on the top, I should put the height on the denominator, and I should do the same thing with the other one. So from here, what I need to do now is just like before, cross multiply. So we got 35x equals 14 times 38. Which we get 532. And now we just divide by 35. So x is equal to 15.2. And then what was our units? Centimeters. Now, because most of the stuff that you're going to be doing in this class is going to have to be like pretty accurate, you have to make sure you keep your measurements. So just keep your centimeters, inches, or whatever else we're using in there. Cool. Any questions on this ones?
Nope.
So the first couple problems on the assignment are just pretty similar to this. They're just asking you to draw the picture, then just work out the problem. So now let's look at the other ones. So let's look at indirectly proportional. So, unlike the other one, where if I'm only looking at the small cone and then I make it bigger, all sides get bigger, right? So the diameter got bigger, the height got bigger. That's what I mean by directly proportional. Indirectly proportional, instead of everything going the same way, what do you think it happens this time?
Everything changes.
Yep, so it goes the opposite. So this is a change in one produces a change in the other. In the opposite direction. So let's look at our first example. So looking at this example, the reason why is indirectly is because think of it this way. How many machines do we start with? 5. Perfect. So we start with 5. How many machines do we have now?
3.
We have 3. And so we know that what happened? We ended up decreasing the number of machines, but because we decreased the number of machines, what's going to happen to our time this time?
It's going to change.
It's going to change. Is it going more or is it going less?
Less. More.
More, because we have less of them, right?
But that's not making fast.
No, you're good. It's because we have less this in this case. So in this case, we used to have 5 of them working, and they used to be able to make them in 1.8 hours. But because we have less of them, we're making less, and so it's taking longer. So that's the complete opposite. I decrease the number of machines, and I increase the number of time. So that's the reason why it's indirectly, and whenever it's indirectly, the other part switches out. So we don't know how long it's going to take, but we do know that it used to take 1.8 hours. The reason is because we decrease number of machines, but instead of decreasing time, it ended up being the opposite. It increased the number of hours.
So it did increase that number.
Yep, and see how it's the opposite, right? Before it used to be increase, increase, or decrease, decrease. But in this case, it went in opposite directions. So now we work this out. So 5 times 1.8. So we got 9
3 hours.
equals 3x. Yep, we divide by 3. And like Andrew just said, it took 3 hours now. Okay, so let's look at one more example, and then we'll be done with the notes. Okay, so on this one, we have the same exact thing as before. We have 2 gears. They're meshed together, so that means they're connected to each other. One of them is going at 360 revolutions per minute, so it's spinning 360 times in one whole minute. The other one's got only 16 teeth, and we don't know how many rotations per minute is, how many revolutions is doing per minute. So how many rotations is it completing in a whole minute? So in this case, we have to think about it again. Is it directly or is it indirectly? So we have the same amount of time, right? 1 minute on each one. And as I complete one full rotation on this one has got less teeth, so I'm making more spins as much as I'm making one in here, right? So I have less teeth, but am I making more rotations per minute? Yes, so that's the reason why it's indirectly. So same thing as before. We used to have 40 teeth, but we're comparing it with something that has 16. Because it's indirectly, we go across. The 40 teeth, how many rotations can I complete with the 40 teeth? 360. And I don't know how many rotations I can complete with that one, so I have to put an X right there. Now that we have this, we can actually try to solve this out. We got 16x on this side, and we got 40 times 360 on the other one. So I got 14,400, and I can divide that by 16 now. So how many rotations per minute am I getting on the smaller one? 900 rotations per minute. All right, so that pretty much is everything for this section. So we're done with the indirect and directly proportions.